Test 1, 2, Test 1, 2, 3. Okay, everybody. So welcome to my presentation. My name is Wolfgang Hinz. I'm the head of sales for Composite and Lightweight Technologies. And today I want to present you the latest composite technologies for lightweight serial productions. My 3 agenda topics for today are, first of all, I want to give you a short background about Cross-Maffei and about our composite technology overview. And then I directly want to jump into the 2 main topics. One is protrusion for serial production of composite profiles. And the other one is fiber form, serial production of thermoplastic composite parts. So some words to Cross-Maffei. Cross-Maffei is one of the leading machine manufacturing companies worldwide, which is representing injection molding machines, extrusion lines, protrusion lines, composite solutions, and a lot of reaction process machineries. We have a very long history with more than 5,000 employees around the world. And yeah, a lot of machine equipment for different solutions. Here, I was trying to summarize an overview about the latest composite technologies which Cross-Maffei is offering. So we are not a part producer. We are providing the turnkey solution or some dedicated equipment for producing this type of parts with these technologies. So on the thermoset composite technology side, we have, for example, high pressure RTM for high structural composite parts, compression RTM, wet molding, pre-preg compression molding, but also some hardware for SMC. Then we have long fiber injection, structural composite spraying, reaction reinforced injection molding. We have equipment for DCPD. Our latest technologies, which we introduced 3 years ago, were protrusion, pull winding, and filament winding. And then we also have some technologies on the thermoplastic side, which are NIRIM for small series, TRTM, so which is thermoplastic RTM, thermoplastic protrusion, fiber form, which I will introduce in the second topic in detail, IMC, which is injection molding compounder, which you are using on an injection molding machine with short fibers, and bulk molding compound. So in total, 18 different composite technologies, and for all these technologies, we are offering the production solution and also have the capability to offer trials in our laboratory or at partners. Coming to the first main topic, protrusion. So for those who are not familiar with protrusion, protrusion is the opposite of extrusion, and it's a technology where you continuously pull fibers, fabrics, or mat and infiltrate them with a resin to produce a constant cross-section, which is a hardened profile, which you can use in a lot of different sectors. And to understand the advantages of protrusion profiles, I have summarized it. So first of all, lightweight. This is a big topic. It's 80% lighter than steel, 30% lighter than aluminum. On a kilogram to kilogram basis, it has a high strength because it's stronger than steel and aluminum. It's easy to integrate several partial parts into one profile. It is corrosion and chemical resistant, so there's no rust like metal or rot like wood. It has a very high durability, so here we are talking about a lifetime up to 50 years with a very low maintenance, which leads in total to a much lower life cycle cost, even if you have a little bit higher invest at the beginning. You can integrate some ingredients to reach a fire resistant, for example, the railway standard. It has a low thermal conductivity, a low electrical conductivity, a low coefficient of thermal expansion, so its dimension is stable. It is easy to maintain the excellent mechanical properties at very high and very low temperatures, and it even gives you the advantage for some applications that you are transparent with your profiles for electromagnetic and radio frequency interferences. And last but not least, it's easy to install, so you can easily drill a hole inside, you can drill some screws inside and so on. And when you understand the advantages, you understand where in which applications it really makes sense to use pultruded profiles. So protrusion is a very wide market. Here, for example, in buildings, there are window profiles, window sill profiles, door frame profiles, glass facade brackets, even some reinforcements in some extrusion profiles, which are replacing steel, or some thermal brakes. Inside the transportation industry, there are different profiles from the automotive sector, transportation chassis, for example, body panels for trains and buses, complete body structures made with protrusion profiles, profiles for cooling trailers because of the good insulation properties, and profiles for drones, consumer goods. There are a wide range of applications which you see here. Construction profiles, fences at airports, for example, to avoid interruption of the signals between the tower and the airport. Handrails, ladder rails, scaffoldings. So all these applications which require a high strength and corrosion resistant. Here in the infrastructure, we have profiles for bridges, rebars in all kinds of applications at the coastal industry, parking garages. Then one of the largest markets and applications are Sparcaps for wind turbine blades, cellular towers, light masts, airports, power cable cores, electrical insulators and cross arms, cable ladders and cable trays, and transmission poles and lightning poles. And in the others, there are, for example, complete oil platforms, cooling tower structures, antenna randoms and radar masts, water park structures, oil extraction rods, flood protection walls, or complete flood dock walkways. And now, out of this wide application range, there are also three main applications where we see the highest focus. On one side, it's window frames, profiles here, for example, it's a skylight made by the company Velux. Why? Because windows are getting larger and larger and therefore also heavier, which require a very strong frame structure. Then with protruded profiles, you have a higher fire safety compared to other structures. You have a better thermal insulation. And here we are not competing against extrusion profiles, we're competing against steel and aluminum window frames. And this technology for this application is already in serial production. The second largest market are Sparcaps for wind turbine blades. Why? Because the wind turbine blades are getting bigger. Protruded Sparcaps are faster than the manual hand layup and infusion process. The technology is already accepted by a lot of OEMs, and it is getting more and more into the acceptance because of cost-driven reductions and also of longer blades. And what we see, there's a renewable energy push, especially in the countries of China and US, where companies are getting a lot of funding to produce parts for this industry. This application is also already in serial production in a lot of countries in the world. And another very important sector is the transportation structural parts. Here, for example, one of our customers where we developed seat cross members for electrical vehicle, which is introduced to the market this year. Why? Because also automotive require lower weight to reduce the CO2 emissions. And here we are competing against high strength steel. And this is also starting to be in a serial production. Here I have prepared a movie which is showing our latest eye-pull protrusion process, where we are pulling fibers directly from the rovings, where we are using a mixing and metering machine, which is dosing two components at a low pressure and feeding it at the right mixing ratio, at the right temperature to the mixing head, where we are mixing the two components and injecting them into an injection box to infiltrate the fibers which we are continuously pulling. And after the injection box, there is the directly connected die, which is heated with different heating zones, where the reaction takes place. So here we are infiltrating the fibers, and here the reaction takes place. And afterwards, we have the clamping and pulling unit, which is pulling the profile, and then afterwards we are cutting it to the defined lengths. By the way, you can also download this movie directly on YouTube if you search for cross-Maffei eye-pull protrusion. There are different variations of the protrusion technology. So cross-Maffei, with our subsidiary Pultrex, we are offering all of them. So there is on one side the traditional protrusion open bars process, where you are pulling fibers and fabrics through open bars. This is the standard traditional process, which is existing on the market for 70 years, where we have more than 600 references on the market. But there is the latest development, which is the eye-pull protrusion process, where we are using an injection box with a mixing and metering machine instead of open bars, always to get fresh and clean material to reduce the waste. And the advantage is that you can increase the speed, so it's faster. If you want to produce a profile which you want to recycle or bring it into a certain shape, you have to use a thermoplastic protrusion process. And here there are 3 variations. So you either can use it in an injection box, you either can use it with an extruder to feed and melt thermoplastic pellets to infiltrate fibers, or you can use pre-impregnated top racks and pull it through a heated die to get a thermoplastic protrusion profile. If you want to reinforce your profile, you either can use mats or fabrics, which are expensive, or you can use a pull winding process. That means you're not only pulling UD fibers, you're also, in addition, winding fibers around the profile. This gives you an additional side reinforcement. Or you can even use a pull braiding process. So that means a braiding unit in front of the standard protrusion line. So you braid a profile around a mandrel, pull it through a die where you use an injection box, infiltrate the profile, and get a reinforced profile. And here I would say it's an additional side reinforcement ×2. For all these technologies, here I forget 2 downstream technologies. You can use pultruded profiles with our fiber form process. So you can heat up thermoplastic pultruded profiles and bring it into injection molding machine and back inject it with some thermoplastic system and with some short fibers. And you can even use it in a co-extrusion process where you co-extrude some surfaces around, for example, for window profiles. And for all these technologies, we are offering low-pressure metering machines, mixing heads, different types of protrusion lines, our own in-house design and manufacturing of the molds, post-processing for milling, punching, quality control, the complete automation around. We have several lines in our headquarters to realize trials, and we have a very strong network in the world with material partners, with institutes and engineering companies to provide feasibility studies and prototyping. Coming to the second technology, fiber form, where we use organo sheets to produce a high series of semi-structural parts, for example, door shells, front bumpers, entertainment covers, airbag covers, seat shells, and a lot of other applications, for example, underbody shields for electrical batteries, but also other semi-structured parts. Here I have also uploaded a movie to YouTube for you, which is describing the process. I will jump a little bit forward because the time is running too fast. Here you see a standard injection molding machine. That means you can add this fiber form automation system to any type of injection molding machine. And the process is working like this, that you are starting from an organo sheet, which is a pre-consolidated fiber mat, which you are storing in material trays. The first robot is coming, picking up the dry organo sheet, placing it on a centering station, the second robot with a gripper is coming, taking the organo sheet, moving into the infrared oven, which is one of the key components of this process, where we are measuring the surface temperature and heating the surface within different heating zones to get a very homogeneous heating up curve. And once the organo sheet is preheated, we are directly moving it into the injection mold, clamping it and back injecting the thermoplastic system, and afterwards you can demold the part. And there are also different combinations. So the standard, what you have seen in the movie, is when you use organo sheets, either glass fiber or carbon fiber, which are pre-consolidated. Then it is possible to use, for example, pre-consolidated natural fibers, which gives you a better insulation property. For example, this is the preferred material for door panels. Then you can use a visible carbon fiber sheet for exterior or interior applications, which allows you to use the fiber form process for producing a Class A surface part. Instead of an organo sheet, you can also tailor-made your sheets with a tape laying system. For example, by the company Phil, they are offering this tape laying system if you want to reduce the waste and vary your thickness or vary the fiber orientation. And last but not least, you can use pultruded thermoplastic profiles to preform it, heat it up, and back injecting them with some grips. And also here we are offering the complete turnkey solution, injection molding machines, the complete fiber form, periphery, molds by our Cross-Maffei partner network, the complete automation, post-processing, quality control, trials in our lab, and a large network. Unfortunately, the time is already over. So if you have any questions, if you are interested in these two technologies, if you are having some projects, please either contact me via email or visit us on our Jack Connect booth and book a slot, and there we can discuss the topics in details. Thank you very much for your attention, and we stay in contact. Thank you very much.